Hi, I'm Kian, and in this video, I'm going to show you how to factor trinomials. Factoring is a very important topic of Algebra 1 and math in general. There are many different ways to factor polynomials, and in this video, I'm going to show you 5 ways of factoring polynomials, with each method having one practice problem. Okay, so I'm going to show you how to factor polynomials by factoring out the GCF, factoring when a is equal to 1, difference of two squares, factoring when a is not 1, and lastly, factoring by grouping. So let's get started. For the first one, we have factoring by factoring out the GCF. GCF, for the greatest common factor, is a way of factoring the polynomial by finding the greatest common factor of the coefficient and the variables. As an example, consider 2a to the power of 4 minus 14a cubed. The greatest common factor of these two terms, 2a to the power of 4 and 14a cubed, is 2a cubed. Why? Because it's common between both terms of the binomial. So, for our final answer, we can write our answer as 2a cubed times, and in the parentheses, we can divide the original binomial by the GCF. So for our final answer, we get 2a cubed times a minus 7. And for making sure that our answer is correct, we can distribute the 2a cubed into the expression and we'll get the same results. Let's move on. For the next example, we have factoring when a is equal to 1. In this example, we have a quadratic trinomial in which the highest power is 2, and the coefficient of the highest power is 1, as you can see. X squared minus 13x plus 42. In this example, we should find two factors of the constant, the c value, or 42, that add up to the b value, or in this case, negative 13. Those two numbers are negative 6 and negative 7. So our final answer would be x minus 6 times x minus 7. And for making sure that our answer is valid, we can always do FOIL and multiply out these binomials. So we get x squared minus 6x minus 7x and plus 42. And when simplifying, we get the original result. For the next example, we have difference of two squares. Consider this binomial, 9a squared minus 100. This is called the difference of two squares, or difference of two perfect squares, because both a and c value are perfect squares. For factoring this, we should take the square root of the first term, 9a squared, which will be 3a, and then the square root of the second term, 100, which will be 10, and change the sign in the expression. So, as an example, as I told you, taking the square root of 9a squared, we get 3a, and taking the square root of 100, we get 10. So we can write our answer as 3a minus 10 and 3a plus 10. And you can see that the only difference between these two parentheses is that there's a plus and minus sign. As I told you, we change the sign between two parentheses. And as always, you can do FOIL to make sure that your answer is correct, and our answer in this case is correct. Let's move on. In this case, in this example, we have factoring when a is not 1. When the a value is not 1, factoring might become slightly harder. In this example, we have a quadratic trinomial in which the coefficient of the highest power is not 1. 4n squared minus 24n plus 35. First, we multiply the a and c value. 4 times 35 is 140. Then we should look for factors of 140 that add up to negative 24. Those two factors are negative 10 and negative 14 because they multiply to 140 and add up to negative 24. Then we can rewrite our polynomial using these two factors. So we can write it as 4n squared minus 10n minus 14n plus 35. Now we can group the first two terms and the last two terms and factor out the GCF. When grouping the first two terms, we can factor out 2n, and so we get 2n times 2n minus 5. And for the last two terms, we can factor out a negative 7, and so we get 2n minus 5. We can see that 2n minus 5 is common, so we can take this out, and for our final answer, we get 2n minus 5 times 2n minus 7. It's very easy. If you practice, it will become much easier. And you can make sure that your answer is correct by, again, doing FOIL. You get 4n squared minus 14n minus 10n plus 35, which is the same as our original quadratic trinomial. Let's move on to our last example, factoring by grouping. Consider this polynomial, 5x cubed minus 40x squared plus 7x minus 56. For factoring this polynomial, We can first group the first two terms and the last two terms and factor out the GCF. When grouping the first two terms, I can factor out 5x squared and the remaining will be x minus 8 plus, and then the last two terms I can factor out the 7. 7 times and then x minus 8 because it's common between both terms. Now I can observe that x minus 8 is common between those the two expressions, so I can take it out. So my final answer would be x minus 8 times 5x squared plus 7. And as always, I can do FOIL to make sure that my answer is correct, and my answer is correct. Thanks for listening, and I hope you enjoyed this video. Goodbye.